Hello. In this video, we will look at adding lightweight APIs to a static website. For example, imagine that we have a website with a newsletter signup and a contact page, but this website is just written in HTML, client-side JavaScript, and CSS. We'll look at a better way to quickly add dynamic behavior to this website through public APIs that have some common sense security controls and integrate with services such that these APIs are very lightweight and simple to set up and maintain. So, for example, imagine we have our users who are on Chrome. We're going to set up that website using Google Cloud Load Balancing and Google Cloud Storage. But if your technology for serving your front end is different, a lot of these concepts will still be quite similar. Now, ultimately, what these APIs are going to leverage is the Cloud Function service. And we'll be able to put this Cloud Function service behind the same global load balancing as with our cloud storage static website files. From there, that Cloud Function will reach out to various services on the internet. And for the sake of example, we'll use SendGrid in our demonstration today, but this could be a really wide variety of different external APIs. Now, when we do this step, it's going to be important to have some basic security in place. Even though we're not going to be allowing read access to some of these APIs, and we'll just be ingesting marketing data from this API service, we do want some security introduced here. For example, some basic rate limiting, bot protection, and DDoS prevention, which we'll get through Cloud Armor. And ultimately, this is actually going to protect our Cloud Function backend. So, requests will be protected before being forwarded along to the service. This is essentially what we'll be creating today, and again, we'll use an example website with the newsletter signup and contact form to show the concepts. Alright, so we're in an IDE now. I'm going to be using Google Cloud's Cloud Shell IDE as a simple example that comes pre-integrated with several services, but there's nothing all that special in this HTML website. We've got the usual markup and styles, and down here we've got some JavaScript that's just using the fetch API to run an API call to either our newsletter form or our contact form API endpoints based on which form was submitted here. So let's get this website deployed real quick, and then we'll add on those dynamic APIs from there. So I'm going to go to Cloud Storage, and in buckets, I'm going to create a bucket called Hello Notomatic IO, which is the domain we're going to use for this website. We'll largely accept the defaults. However, we do want to turn off public access prevention, as we'll need to make these static website files public so that users can access our website. Let's now copy our index.html file to that new cloud storage bucket and confirm that it's in our bucket. And there it is. Now let's set up the networking in front of this bucket. So we're going to use Google Cloud's load balancing service for this. And if you haven't set up load balancing, just make sure that you turn on the Compute Engine API, as the networking services are backed by some of these capabilities. And with that API now enabled, let's go to the network services and specifically cloud load balancing. So let's create a load balancer here, and we want the new HTTP global load balancing for the website. We'll be extending this exact same load balancer once we add those APIs in just a moment. We do want to use HTTP. And to be able to do that, we need to create a static IP, at least if we want the HTTP to HTTPS redirect. And once we add our API service, we'll also want to be able to use HTTPS for that. So I'm going to add both domains in advance here to our managed certificate, and we'll need to point some DNS A records at this load balancer to ensure everything provisions once we're done with the setup here. In our backend configuration, we need a backend bucket since that's where our static website files are hosted. Let's turn off CDN for now to keep things simple, but just keep in mind that we could cache files for this website if we wanted to potentially improve performance. And we did talk about Cloud Armor a little bit, the security layer that we're going to put in front of our API, but we're not going to use that for the website itself, even though we could. That is the HTML, CSS, and front-end JavaScript files. But these could also be added later if we decided to do that. So for now, we'll just route everything to that host with the simple host and path rule, and let's create the load balancer. And once that load balancer has provisioned, let's click in and grab that IP address. Now, for this certificate to provision, we need to add A records for all the domains that are included in the certificate. In our case, that is hello.notomatic.io and api.notomatic.io. We need to point those domains to our IP for the load balancer, and then Google will be able to run the HTTP ACME challenge to provision the certificate and give us the SSL termination that we'd like here. So on a different screen, I'm going to add those two DNS records. And of course, this could be in any DNS provider. It doesn't need to be Google Cloud's DNS. So this is still going to take a couple minutes, even once you've added those records. Typically, we see the provisioning take about 10 minutes for those SSL certificates. So while that's running, let's go ahead and go back to our cloud storage bucket and just sanity check our permission setup there, because right now we do not have public access. We're going to need to add that for our website to serve those files. So in the permissions here, let's go ahead and go to grant access and then add all users and grant them the role of object viewer so they'll be able to view our static website files without any authentication. We'll get a warning that this is going to make our website public, but that is exactly what we'd like here. So now we have public access, and in fact, we could test that by just going to the public URL here, and we see our website. Now, of course, we want our load balancer to finish provisioning that certificate so we can access the website on our hello.notomatic.io domain, but this is a good sanity check for us, and we've got our website here. Again, while our certificate is provisioning, let's start talking about how we're going to set up this API. Specifically, we're going to use Cloud Functions for that, which will give us a really lean and lightweight way to set up an API. We'll enable the required APIs when we click to create a function. And now I have the creation screen, so pretty shortly we're going to need to provide code for this Cloud function, and we haven't created that yet together. But just to give you an idea, what we're providing in this specification is some Python code, and we're also going to make this endpoint public so that our website users from their browser client can hit this API to send us some marketing data like new newsletter subscriptions. Let's go back into our IDE and now set up this function. We're going to need the function code itself, as well as the requirements file, since we're going to use some client SDKs. Now again, I mentioned that we're going to use SendGrid as an example. So I will paste in some requirements for our function. We're going to need to use the functions framework, which is just standard for Cloud Functions, and then we'll use the SendGrid Python package as well in our function. Now this is a decent amount of code, but it's going to cover both the contact form and the newsletter signup, and I think we'll be able to walk through it relatively quickly. So we've got some imports at the top here, and then our entry point, which is what our Cloud function is going to run upon every request that hits this API. So up front, we're handling some cores because of our website running on hello.notomatic.io, but we have our API on api.notomatic.io. We need to handle the fact that there are different domains involved here and allow that hello origin to hit our API so that we're going to do that here. And then we're providing the allowed methods and headers for those requests. So this is just going to run if we have an options method, and that's for the cores pre-flight. Essentially, the browser checks in advance before submitting the request if there are any cores policies that are going to be violated by using a pre-flight request. So this set of about 9 lines of code handles all that. Next up, we have our main request. That is, after the pre-flight, our post requests that we're going to get from our website users. We've got some cores headers that we're going to supply on every response, and then we're going to take a couple different paths depending on the URI path that we get in the request. For our newsletter signups, we're going to get the email from that request, create data for SendGrid, and we're going to be adding this email to a contact list in SendGrid. Then we're going to be using the SendGrid API client to add that contact. Now, we could hit the API directly using a general purpose HTTP request framework like requests in Python, but using these client SDKs tends to simplify things. So we're going to do exactly that and use the SendGrid package to make our lives easier with just a couple lines of code to add that contact. Based on the result of that, we'll return a status code. Next up, we've got our contact form, which has a couple more form fields, and we're going to be sending an email message with the information about that contact request. So again, we're going to be using the SendGrid client SDK for that, and we'll be returning a response code based on that. Now, oftentimes, we don't want to use the error codes directly that we get from the SendGrid API client and return those in our API responses because we really don't want our users to have that level of information about what's going on in the backend here. And if we get a request to a path other than those two that are specified in this if and else if block, then we're just going to return a 400 error. So in all cases, we're returning a status code, an empty response, and some chorus headers. We could add some additional checks here. Like, for example, you could potentially check for a header to match a specific value, some sort of token that you're injecting on the client side. However, just keep in mind that these are fundamentally public requests, and we're avoiding any sort of website backend here. So your front-end code, if you have a token in there, for example, that's going to be exposed directly to your users. We'll talk about ways that we can control this API in other ways beyond doing authentication methods because, again, we want our website users without being logged in to be able to subscribe to the newsletter, for example. So let's go ahead and take this code and paste it into our Cloud function. I'm actually going to do that off screen because I need to provide an API key for this SendGrid API client. You see this is empty here in both of our two cases, so I'm going to do that off screen. But essentially, I'll just be copying the code into this Python 3.11 main.py and requirements.txt and make sure that you change the entry point here to entry point. So much like this, we'll be copying our code in for both the main Python code as well as the requirements. And if I reload the Cloud Functions page, we'll see that new Cloud function showing up for our newsletter signups and contact form submissions. So this is looking good. We just need to wire this up now into our load balancer. But let's actually check to see if that load balancer is now serving our website. And not quite. We do have to make one last change here, but very close. To ensure that Google knows that we want to serve this bucket as a website, we just need to use this gsutil web command and set the web page that will serve requests for this bucket. And then, when I reload the page, we'll get our marketing website. This is great. So if I inspect the elements here and look at the networking panel and our developer tools for the browser, if I submit an example email here, we're going to get an error because we haven't yet set up that api.notomatic.io API yet. So let's go ahead and do that now together. So in our load balancer, let's just update that routing to include our new API backend. This is going to involve creating an entirely new backend, and it'll be a backend service, and specifically a serverless network endpoint group. We'll skip using Cloud CDN, and since our Cloud function is a version 2 Cloud function, it's actually backed by Cloud Run, so we'll see the service here. Everything else looks good, and again, we'll add Cloud Armor just a little bit here. So we've got both backends represented. We just need to decide how to route between them. The simple host and path rule should be fine here. By default, we're going to serve from our hello.notomatic.io bucket, but for api.notomatic.io requests and the two paths that we decided, we're going to serve from the marketing ingest service. Great, so now let's update that load balancer and then we'll test things out. Once we refresh our page, we can submit our form and we'll get a successful submission to SendGrid. Here's a screenshot from SendGrid where we have that email now in our contact list. And here's a screenshot from Gmail. So we've successfully wired up a lightweight API. As a last important step, we do still want to secure this API with things like rate limiting and potentially reCAPTCHA. So if I go in to edit this load balancer and the backend for our API specifically, let's now look at how we can add a Cloud Armor policy. We'll actually do that in the Cloud Armor page itself and create specifically a backend security policy. We want our default rule to be allow and then add adaptive protection prevention. We'll add some rules using the gcloud command in just a moment. We also want to add our target, so that's our marketing ingest load balancer backend. This will create that policy, and then using a gcloud command, we're going to add a rule onto that policy. So this rule is just a little quicker than walking through a bit of complicated interface in the UI here, but it's going to add rate limiting to the marketing ingest, allowing up to 5 requests per minute. We don't want to be getting a lot of newsletter subscriptions or be flooded with contact form requests. Similar to this policy here, we can actually add things like reCAPTCHA to protect our APIs from bots and use other mechanisms so our APIs are secure and well controlled. If I go into our load balancer, we should now see on that backend that our Cloud Armor backend security policy is being applied. And with that, we've got some nice protection measures for some lightweight APIs that we can use to power our otherwise simple and static websites. We hope this tutorial was helpful, and we want to thank you for watching.